You may have heard the term LFET or low frequency electromagnetic technique in some of our previous videos, but you may not be familiar with what it is. LFET was developed by TesTex as the means to quickly inspect ferrous and non-ferrous metals to determine where corrosion and pitting are occurring. We do this by driving a low frequency electromagnetic field through the metal and measuring the return strength of that signal. Where metal is thinned or pitted, the return signal is greater, allowing us to pinpoint those spots. Our LFET scanner has multiple pickup channels that allow us to pinpoint the areas that have pits. Here we have a cutout of a tube. It is a 2.5-inch OD with 203 mils nominal wall thickness. We will be scanning this piece at 10 Hz. As we scan the piece, you can see the C-scan picking up the flaws. The flaws in this piece include thinning throughout the length of the tube with two major areas of pitting. We've marked the first area of pitting here and the second area here. When I flip the tube over, you can see both areas with major flaws. We can see the orientation of the flaws matches the actual flaws because this is a multi-channel system. Because the LFET is low frequency, it will pass through non-magnetic substances such as paints, coatings, and wraps. To demonstrate this, we are going to use a newspaper between the test piece and the scanner. As you can see, the flaws are still visible through the newspaper. This is an Inconel-clad carbon steel boiler tube cutout. It is a 3-inch OD with a 300 mils nominal wall thickness. Because Inconel is a non-magnetic material, we are going to use LFET to detect this flaw. You can tell this is a major flaw by the way it shows up on the C-scan. At 10 Hz, we're not even seeing the Inconel, but only the base metal carbon steel below. The flaw is actually in the carbon steel itself. This flaw shows up perfectly using LFET. LFET enables you to quickly determine where your flaws are, and while it is quantitative, we also use UT A-scan thickness readings on the spot to prove up our findings. Some other technology we have that uses LFET includes our tank floor scanners, pipe scanners, tube scanners, the LineCat and LineCat Plus, and our LFET internal diameter scanner. Applications for this technology include water walls, tank floors, tanks, pipes, pipelines, and vessels. TesTex has developed LFET for rapid flaw detection. Our software, electronics, and scanners are all manufactured and developed at our Pittsburgh office as part of our dedication to provide fast, accurate, and cost-effective non-destructive testing services and products to our clients. Because at TesTex we know, your turnaround depends on our turnaround.